telephones in your house to this adapter. Because remember, the idea with voice over cable TV is you've got your cable modem and your PC and they're connected together with an Ethernet LAN cable. And what we're going to do is get a little adapter box from the cable company that sits in the middle. So you plug your computer and your POTS phone into it, and this device does the regular telephony to voice over IP conversion. It's got a little gateway in there, and it does part of the gatekeeper functions and things like that for negotiating. But this has just got one jack on the thing, so you could take one phone and plug it in there. How do you plug all of the other telephones in your house onto this jack? Well, if you're an electrical engineer who likes fooling around with telephone wires, like some people I know, you could figure out how to take the inside wiring in your house and terminate it on one of those little RJ11 jacks, the ones that are on the end of the phones. And so you take your inside wiring and plug it onto this telephone jack on the adapter box, and then yes, all of the telephones in your house. But how is my aunt going to figure out how to do that? Her VCR flash is 12. There's no way she could figure out how to take her inside wiring for her telephones and plug it into a jack and an adapter box that was designed to plug one telephone on there. So this is a bit of a thorny issue. Finally, the question again comes down to quality and price. And just keep in mind that this is purported to be internet telephony, and as far as I can tell, the reason for that is to avoid regulation and the associated fees. Chances are real good that it's not going to run over the internet. It's either going to run over a commercial IP network long distance, or it's going to be turned into a regular phone call at the earliest opportunity and then carried like a regular phone call. And in both of those cases, the regulators are going to say, aha, that's not internet telephony. That's regular telephone service being carried over a commercial network. So therefore, you've got to pay the universal service fee. So while it might sound like it's going to be cheaper to start, there's no reason to believe that that's a long-term story. It's going to end up being equal cost to everything else. One market for voice over IP is to government and business, where the salesperson will come in and say, let me show you how we can save you money. You've already got T1s, dedicated T1s connecting these locations together, and you're using these for data, plus you've got voice tie lines and watts and dialed phone calls going between these same locations. Well, tell you what we can do. If you buy 2 of our boxes and stick it one at each end of this dedicated line, then you can take not only the data in IP packets that's going over this, but you can also take all the voice and convert it into voice over IP, and then you can intersperse the voice with the data over the existing line and eliminate all of the tie lines and the dial-up phone calls between those same locations. So you're leveraging the cost of your existing wide area network for data by now running voice over it for free. And since it's running over a dedicated T1, if you buy 2 of our boxes and stick one at each end of the T1, then we can guarantee the voice quality because we can cheat and give the voice a higher priority than data on a dedicated line. And it'll all sound great. And this all sounds great. But the whole premise of this story is that, one, you've got dedicated lines between your locations. And you may well have, but going forward, there are going to be a lot of cheaper ways to do communications and get dedicated T1s between your locations. But even if you do have dedicated T1s, the premise of this whole sales pitch is that you're not using those T1s efficiently and you could use them more efficiently. But let's just take a closer look at that. We start thinking, well, typically, right now, what would be happening is that let's say that you've got a pure data story, so it's just data running over the T1. But typically, all of the stuff in this building is going to be running at 100 million bits per second. That's the speed that LANs run at. All the stuff in this building is going to be running at 100 million bits per second. And we're connecting those together with a T1. That's 1.5 million bits per second. So 100 million here, 100 million there, and the connection between them is 1.5. And we've got spare room on that we can put more stuff. I think if you back off from the sales pitch and you examine the premise of the sales pitch is that you have spare capacity on your existing wide area network, it's probably not true. In fact, people are probably already complaining that that wide area network is pathetically slow and they need more capacity on it just for the data. Now, another scenario would be we have a dedicated T1 and we've channelized it and we're using, let's say, half of it, so 12, a T1 can have 24 channels on it. 12 of the channels are used to do data, so it's a router-to-router connection at half of a T1. And then the other half of the T1 is channelized, and that's 12 tie lines going back and forth between the locations for doing circuit-switched regular phone calls. The idea here is that instead of channelizing the T1, we'll just turn it into a big 1.5 megabit per second pipe and we'll put everything in IP packets. Now in this scenario, you would end up, yes, using what used to be those 12 channels much more efficiently, because in traditional telephony, one of those channels is reserved during a phone call between the two locations, regardless of whether squeaking noises are coming out of your face or not. And if we don't channelize it, instead we send packets interspersed one after another using the whole thing as a big pipe, then we can get more efficient. But we have to start talking about prioritization, because voice quality is important. If we implement a voice over IP system and it sounds lousy to users, that's what you're going to hear about. You're not going to hear about any savings. You're going to hear complaints about voice quality. And so what we're going to have to do if we start interspersing voice and data on a limited capacity circuit like a T1 is we're going to have to start doing prioritization to give the voice higher priority than data. And then the questions come into play as well, okay, but what happens at 1 o'clock in the afternoon when everybody starts making phone calls? Will the voice have such a higher priority that it starts kicking a lot of data traffic off? It can't go through anymore. It just gets rejected at the entry point to the T1. So what's going to be the effect on the client-server response time for looking up that client's insurance records while you're talking to somebody on the phone at the same time? If we don't prioritize the voice, then what's going to happen is that when somebody's doing a huge file transfer across that dedicated line, if there are too many people making phone calls as well, is we'll start losing packets and having variable delay in the delivery of the packets. Now, that doesn't matter for data because we can retransmit, but in a live voice conversation, a chunk of data getting lost or arriving late, that's the same thing as not arriving at all. There's no time to retransmit it. So we've got this sort of trade-off here as well. We can prioritize the voice. That might end up drastically affecting the data client-server response time. Or we can not prioritize the voice, but then if there's a lot of data traffic, the voice quality goes south. When we're looking at sales pitches like this, where they're saying you can use what you've got more efficiently, do voice communications for free over your existing data T1s, you would want to say, yes, that might be true, but then take a look at what the loading of those T1s already is. And chances are pretty good you're going to find out that they're already overloaded and there is no room for more traffic on them. In fact, people are already complaining that they're too slow. Free moves and changes are a good thing, and this may turn out to be one of the really big advantages of voice over IP. As we said in the introduction, the idea with traditional telephony is that we have a person, a network address, and services all associated with a pair of wires. And the idea is if you change to another room that has a different pair of wires terminating in it and plug your phone onto those, then a technician has to go down to the telephone room and either take the pair of wires leading from the new cubicle and plug them into where your old pair of wires used to be plugged into, or sit down at this computer we call a telephone